Hello everyone, I hope you're doing well today. Today we are going to learn about exponential functions. An exponential function is a function in the form of f of x equals a times b to the x, where a is a constant, b is the base, and the independent variable x is the exponent. A set of ordered pairs satisfies an exponential function if the y values are multiplied by a constant amount as the x values change by a constant amount. Let's take a look at a few examples and determine if they are satisfied by an exponential function. Looking at my first set of ordered pairs, the x's are 2, 4, 6, and 8. The x's are going up by a constant amount of 2 each time. Looking at the y values, to get from 4 to 8, we multiply by 2. To get from 8 to 16, we again multiply by 2. To get from 16 to 32, we multiply by 2. Since my x's are going up by a constant amount and my y values are each being multiplied by a constant amount, this is an exponential function. Looking at the second set of ordered pairs, starting with the x values, I have -5, 0, 5, and 10. They're all going up by 5 each time. So then I start looking at my y values. To get from 1/3 to 1, I have to multiply by 3. To get from 1 to 3, I multiply by 3. And to get from 3 to 9, I also multiply by 3. Since my x values are going up by a constant amount each time, and my y values are being multiplied by a constant each time, this set of ordered pairs also satisfies an exponential function. And looking at the last example here, my x values are 1, 2, 3, and 4. They are all going up by a constant amount each time. They're all increasing by 1. So now I look at my y values, 750, 150, 3, and 6. To get from 750 to 150, I multiply by 1/5. To get from 150 to 30, I multiply by 1/5. And to get from 30 to 6, I also multiply by 1/5. Since my x values are going up by a constant amount each time, and my y values are being multiplied by a constant amount each time, this also satisfies an exponential function. Please take a moment to pause this video, record the definitions and the examples in your notes. Now let's try graphing exponential functions. To graph an exponential function, you just need to make and graph a table of values. So I've already got our table started up over here, and we're going to graph the function y equals 2 times 3 to the x. So let's start plugging in our values. If I plug in -2 for x, I get y equals 2 times 3 to the -2. Remember, the rule is with negative exponents, we're going to take our 3 to the -2 and make it a fraction over 1, and we flip the fraction and get 1/3 and make the exponent positive. So 3 to the -2 is really the same as 1/3 to the +2. 1/3 to the second would be 1/9 times 2 gives me 2/9. So when I substitute in -2 for x, I get 2/9 for a y value. Now let's try plugging in -1. So I get y equals 2 times 3 to the -1. Well, 3 to the -1 is really the same as 1/3 to the first. 1/3 to the first is 1/3 times 2 gives me 2/3. So I have the point -1, 2/3. Next, plug in 0 for the exponent. So I get y equals 2 times 3 to the 0. Remember, anything to the 0 power is 1, So I really just have 2 times 1, or 2. So when I plug in 0 for x, I get the point 0, 2. Now let's plug in 1 for x. So I get y equals 2 times 3 to the 1. Anything to the first power is itself, so I really just have 2 times 3, or 6. And the final value I plug in for x is going to be 2. So I have y equals 2 times 3 squared. 3 squared is 9, and 2 times 9 is 18. Now that I've created a table of values, I need to plot my points. Once I have plotted my points, I just need to connect them with a smooth curve. Now whenever I raise something to a power, I'm always going to have a number greater than 0. So here our line will approach the x-axis and keep getting smaller and closer to it, but it will never cross it. And now we have graphed the function y equals 2 times 3 to the x. The function is approaching is negative 2. Now let's try another example. Let's graph the function f of x equals 3 times 2 to the quantity of x minus 1 minus 2. Again, I'm just going to make a table of values. So let's start off by finding f of negative 2. When I plug in negative 2, I get 3 times 2 to the negative 2 minus 1 minus 2, which gives me 3 times 2 to the negative third minus 2. 2 to the negative third is the same as 1/2 to the third. 1/2 to the third would be 1/8. So I have 3 times 1/8 minus 2. 3 times 1/8 is 3/8, and 3/8 minus 2 is negative 13/8. Next, I'm going to find f of negative 1. So I get 3 times 2 to the negative 1 minus 1 minus 2. So 3 times 2 to the negative 2 minus 2. 2 to the negative 2 is the same as 1/2 squared. 1/2 squared is 1/4. So we have 3 times 1/4 minus 2. 3 times 1/4 is 3/4 minus 2. 3/4 minus 2 is negative 5/8. Now I'm going to find f of 0. So I get f of 0 equals 3 times 2 to the 0 minus 1 minus 2, which is 3 times 2 to the negative first minus 2. 2 to the negative first is the same as 1/2 to the positive 1, or 1/2. So I have 3 times 1/2 minus 2. 3 times 1/2 is 3/2, and 3/2 minus 2 is negative 1/2. Next, I'm going to find f of 1. When I substitute in 1 for x, I get 3 times 2 to the 1 minus 1 minus 2. 1 minus 1 is 0, so I have 3 times 2 to the 0 minus 2. Anything to the 0 power is 1, so I have 3 times 1 minus 2, or 3 minus 2, which is 1. Finally, I'm going to find f of 2. So I get f of 2 equals 3 times 2 to the 2 minus 1 minus 2, or 3 times 2 to the first minus 2. 2 to the first is 2. 3 times 2 is 6. 6 minus 2 is 4. So my final point is 2, 4. Now I'm going to take a moment to plot my 5 points. Now that I've plotted my points, I'm going to finish my graph by connecting them. In this case, since I have that minus 2 at the end, my graph has been shifted down 2 units. So my line and my function will get close and close to y equals negative 2, but it will never cross it. Now we have graphed the function f of x equals 3 times 2 to the quantity of x minus 1 minus 2. Please take a moment to pause this video, record this example in your notes, as well as any questions you may have. Take care, stay safe, and be well. I'll see you in the Zoom meeting shortly.